Welcome to EDU World Space.
Okay, so this is the free body diagram for this question. So consider the direction along the surface is x-axis, and the direction perpendicular to the surface is the y-axis. So let's apply the force equilibrium for this question. So the net force along the y direction can be equal to n plus p sine phi minus w cosine alpha, which is equal to 0. So I have normal force N is equal to w cosine alpha minus p sine phi.
Of the work energy
And
theorem,
the net force along the x direction is equal to p cosine phi minus f minus w sine alpha is equal to 0. Therefore, p cosine phi is equal to f plus w sine alpha.
For object A, FA
and we know F here is the static friction. I'm sorry, not static friction. In this case, it's the kinetic friction. And W here is the gravity of
and
the
force
objects.
ratio frac FA, FB
So
equal frac 0.10, 0.15.
now we also know that the friction can be equal to mu Kn. Mu K here is the coefficient of the kinetic friction.
Would you like a PDF version of this
and
explanation?
We can use mu Kn substitute for F. So we have P cosine phi is equal to mu Kn plus W sine alpha. And remember, normal force N can be equal to W cosine alpha minus P sine phi. Therefore, we have P cosine phi is equal to mu K times W cosine alpha minus P sine phi plus W sine alpha. So in the question, you was given that angle theta can be equal to inverse tangent mu K. Therefore, the coefficient of the kinetic friction can be equal to tangent theta. So now we can use tangent theta substitute for mu K. So we have P cosine phi is equal to tangent theta times W cosine phi minus P sine phi plus W sine alpha. Therefore, we have P cosine phi minus tangent theta times W cosine alpha minus P sine phi minus W sine alpha is equal to 0. So now we can do some rearrangement here. So we have P times cosine phi plus tangent theta sine phi minus W tangent theta cosine alpha plus sine alpha is equal to 0. So we have P is equal to W times sine alpha plus tangent theta times cosine alpha over cosine phi plus tangent theta times sine phi. Remember, tangent theta can be equal to sine theta over cosine theta. Therefore, we have such equation here. So now let's multiply by cosine theta up and down. And this will give us force P can be equal to W times sine alpha cosine theta plus sine theta cosine alpha over cosine phi cosine theta plus sine theta sine phi, which is equal to W times sine alpha plus theta over cosine phi minus theta. So now, in order to determine the angle phi, we need to differentiate the force P equation on both sides. So we have dP over d phi, which means that we need to differentiate the force P on both sides with respect of angle phi. That's how we determine the angle phi. So we have dP over d phi is equal to W sine times alpha plus theta times sine phi minus theta over cosine phi minus theta is equal to 0. So since we know the value under the denominator cannot be equal to 0, therefore the only value or only variables that can be equal to the 0 is W sine alpha plus theta times sine phi minus theta is equal to 0. And this gives us two options here, which is W sine alpha plus theta is equal to 0 and sine phi minus theta is equal to 0. And the variable one is phi minus theta is equal to 0. And this will give us, let me see. So these two equations here give us phi minus theta is equal to 0, which means that phi is equal to theta. So now we have the answer for angle phi. So angle phi is equal to angle theta. So now, in order to determine the corresponding force P, we just simply use angle phi substitute for angle theta. So we have P is equal to W sine alpha plus theta over cosine theta minus theta. And this term here can be equal to cosine 0, which is equal to 1. Therefore, eventually, we'll have the force P is equal to W sine alpha plus theta. And this is the answer for this question.